Hello info person, this is Anton, and today we're going to discuss one of the more unusual supernova remnants discovered in the Milky Way galaxy that up until a few years ago remained completely mysterious. But completely by accident, just over a decade ago, an amateur astronomer discovered the remnant looking for something entirely different, in the process helping us solve several mysteries, but also helping us discover potentially one of the more unique supernova we've discovered so far, and a supernova remnant that actually started unusual emissions just over 20 years ago. And so let's talk about this a little bit more, but let's also start with ancient history that helped us identify where to even look for this particular supernova by looking at some of the more ancient texts from Japan and China. And this is technically now becoming a kind of a new field in astronomy that's sometimes referred to as astronomical archaeology or archeoastronomy, which in essence focuses on various archaeological findings in order to discover how the night skies were different back in the days, or in order to identify very powerful events such as nova and supernova. And back in the days in ancient China and even in ancient Japan, quite a lot of astrologists were able to directly pinpoint the appearance of these so-called guest stars that would exist in the night skies for a few months and would then disappear into nothingness. And today we know that these were very likely very powerful nova or supernova in the Milky Way galaxy. And as of 2024, 5 such supernova have been confidently identified by using some of these ancient texts and then comparing them to various remnants we do see in the night skies. And so in 1181 AD, several astronomers, or I guess astrologists, mostly because in ancient China and in ancient Japan their job was actually to use the stars to predict the future, detected a new guest star. A star that appeared to be just as bright as Saturn and existed in the night skies for approximately 180 days. And based on 8 separate texts from China and from Japan, it was tracked to the location you see right here to a potential remnant known as 3C58, which just happened to be a pretty well-known pulsar and was definitely a supernova remnant located about 10,000 light-years away from planet Earth. But here there was a small problem. Based on radio and X-ray observations, this pulsar was spinning approximately 15 times per second, and that was maybe a little bit too fast compared to what it should be spinning after 1,000 years. For example, the iconic Crab pulsar, which was formed around the same time, was spinning much slower. And that's because we expect these neutron stars to lose up to 2/3 of their rotational power over a 1,000-year period. Furthermore, additional observations possibly established that this was actually much older, very likely at least 3,500 years old, making this supernova remnant very bizarre compared to what's expected based on its age. And so the mystery here was that, despite the location, this remnant might have actually been incorrect, as in this was a supernova from some times ago, but was not the one we're looking for. And then, completely by accident, in 2013, Dana Patrick, an amateur American astronomer, discovered this. At first this was only seen in the infrared light, but was surprisingly in a very similar location. Now he was actually not looking for supernova remnants, he was looking for planetary nebula. But to his surprise, the 30th object he's ever discovered, the object now referred to as PA30, turned out to be that supernova remnant we were looking for this whole time. And at first it appeared as a very bright infrared orb that seemed to be extremely faint in optical light. But eventually the X-ray examinations discovered additional properties with visible shock waves and also unusual tendrils that are actually kind of mysterious, and we've discussed them in one of the videos in the description. But most importantly, right in the middle, there was something super hot with extremely powerful stellar wind. The wind that was expanding at 16,000 kilometers per second. And the wind that was mostly made out of carbon, oxygen, and neon. No hydrogen, no helium. Which essentially suggested that this was an unusual white dwarf. And that possibly did not make sense at first. But it was confirmed to be a white dwarf, and was also confirmed to be possibly the hottest star in the Milky Way, approximately 200,000 Kelvin. And so because of these very bizarre observations, it suggested that this is a unique object, possibly even an object we've never really seen before. And eventually it was established to be some kind of a super heavy white dwarf, possibly heavier than a typical white dwarf should be, so basically over 1.4 solar masses, and a white dwarf surrounded by various filaments, very powerful stellar wind, and a lot of other bizarre structures. But most importantly, The actual age and the location match the observations from ancient Japan and ancient China. And so this was indeed the supernova we've been looking for this whole time. But what exactly formed this, and what exactly are we looking at? Well, it turns out that this is probably the result of an extremely rare event, sometimes known as Type 1ax supernova, where two slightly different white dwarfs collide, leaving behind a single supermassive, rapidly spinning white dwarf that seems to produce a lot of very powerful emissions. And though typically we expect these white dwarfs to be destroyed producing a supernova, there is a supernova, but there's also what's known as a zombie star left behind. And by itself, this is maybe not as unusual as it sounds. We know that the Milky Way galaxy has a lot of binary stars, and most of these binary stars are not so different from our Sun and from a lot of different red dwarfs. A lot of these stars eventually become white dwarfs, thus producing binary white dwarf systems. And as these white dwarfs orbit each other, they start producing gravitational waves that slowly make them come closer and closer and eventually merge. But in the majority of cases, this merger just produces a very powerful explosion, most likely leaving nothing behind. But it looks like in some cases, extremely rare cases, a merger of a carbon-oxygen white dwarf with an oxygen-neon white dwarf produces a very powerful remnant shell and a supermassive white dwarf. And also a white dwarf with some really extreme properties. For example, a lot of this is actually powered by residual radioactive decay from, for example, isotopes of nickel. And though normally some of these isotopes have a typical half-life of about several days, in these extreme environments, a lot of these isotopes become ionized, preventing them from decaying for hundreds and hundreds of years, which essentially forms an extremely powerful object with a lot of powerful emissions, lots of heat, lots of radiation, and extremely powerful stellar winds. But it's really some of these recent discoveries from the research you can find in a description that basically makes the star even stranger. Here, the team discovered that a lot of these super powerful emissions actually only started 20 to 30 years ago. With all of this discovered in the X-rays, by looking at this remnant, because this remnant contained unusual layers, suggesting several emissions over time. And so by creating a computer simulation to try to explain this, which was actually done just to understand why this unusual white dwarf was produced, here the researchers discovered that a lot of this stellar wind seemed to be kind of variable. In other words, the white dwarf was not always as powerful and was not always emitting so much powerful radiation. But most importantly, these observations would only make sense if a lot of this powerful stellar wind only began sometimes in the 1990s or basically 20 to 30 years ago, which by itself is very surprising, but also suggests something really important. This white dwarf is still quite active and seems to still possess some kind of a nuclear reaction that produces all of this. In other words, this white dwarf is still burning, which by itself makes it not a white dwarf already, and some kind of a very peculiar star we've never seen before. And so basically, the only way to explain these unusual double X-ray shockwaves is to have these emissions start sometimes 20 to 30 years ago or 800 years after the supernova. And the only thing that makes sense right now is some kind of a carbon burning, which seems to have started as a result of a contraction of the white dwarf, where the oxygen neon core starts to burn carbon inside. And if the scientists here are correct, this actually presents us with even more questions and also potentially some really important discoveries. For example, for all we know, this is going to go supernova again and possibly in the near future. Likewise, this is maybe not even a white dwarf and instead is some kind of a hybrid star that seems to still produce very powerful emissions and has a type of a nuclear reaction we don't really associate with white dwarfs. And so because of this, the scientists are now trying to investigate this using other frequencies and are hoping to now use very large array telescope along with the Subaru telescope to try to learn more about this unusual object. Either way though, whatever is inside this bubble seems to be very unique, very unusual, possesses properties we've never seen before anywhere, and most importantly, seems to be very unpredictable and for all we know could actually go supernova, maybe even in our lifetimes. I mean, assuming the scientists here are correct and these emissions started only 30 years ago, here we don't even know how long this is going to last and what's going to happen to this object afterwards once it runs out of material. Now normally, in a more massive star, this carbon burning process takes approximately 600 years to maybe 1000 years in total. And so in this case, for a much smaller star, we have no idea how long this is going to take, but it's probably going to be much shorter, possibly even just decades, which basically means that it might actually have just a few decades left before something else changes. And so for all we know, maybe we could witness a supernova in the Milky Way after all in our lifetimes. But that's of course just speculation for now. The supernova here is probably still going to happen, mostly because this is a supermassive white dwarf, but at this point it's not assumed to happen anytime soon. Either way, I'm sure in the next few years we'll hear more about this, because this object is definitely super mysterious and is one of the more anomalous objects in the entire Milky Way galaxy. Not to mention, obviously, the hottest and producing some of the most powerful stellar winds in the vicinity of planet Earth. And so once we have some more discoveries, we'll come back and talk more about this in some of the future videos. Until then, check out previous videos in the description. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining the channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.